Greetings. We're going to be talking today in Algebra 2 about writing equations of lines if we continue to explore slope and different derivations on the slope form. So our main ideas today is we're going to be hitting three main ideas of slope: point slope form, standard form, and slope intercept form, as you can see from our three equations here. First of all, point slope form is focused on our form right here in this blue box. Inside the blue box, obviously we have m as the slope and x1, x2 as the point. Second main idea is standard form. Traditionally, standard form is written with a, b, and c being integers, x and y being on the left-hand side, and x coming first for a standardized approach that allows us to work with systems of equations. The third form that we're going to be working with is the more familiar form for graphing, which is slope-intercept form, y equals mx plus b, where b is the y-intercept 0, b. So let's take a look at a couple examples as we kind of work back through this and do some review, and hopefully we'll have a good understanding of all three forms by the time we're done with our lesson here. All right, our first example uses the idea of using slope and a point, and we're asked to write the equation of the line in all three forms above. All right, first off, we're going to really start off with point slope form, because point slope form is the easiest form of all to write. And so I'm just going to rewrite that form down here. Y minus y1 equals m times x minus x1. Now we need to realize what our x1 and our y1 points are. So that's x1 there, that's y1 there. So all we're going to do here is just put our points in, and we're going to have our point slope form. So y minus a negative 3 equals our slope times x minus 4. Final version is going to be y plus 3 equals 2 times x minus 4. And this is going to be our point slope form. All right, from point slope form we can go in two different directions. We can either go first to standard form or second to slope intercept form. It really doesn't matter, but the key is understanding that that's going to be our first primary one. Let's go to the standard form, which is ax plus by equals c. All right, to go to standard form, the first thing we're going to do is we're going to distribute the 2 to get 2x minus 8. The second thing we're going to do is we're going to move all the numbers over to the right. So we're going to subtract 3 from both sides. That gives us y equals 2x minus 11. Well, I'm going to pause here because without realizing it, we've instantly jumped to the idea of of slope-intercept form, because we have m is 12 and the intercept is 11. Going from here to standard form is very simple. We're going to subtract 2x from both sides. That gives us negative 2x plus y equals negative 11. And I have to honestly say most books are going to write it as 2x minus y equals positive 11, because they're going to multiply everything on both sides of the equation by a negative 1. So finally, in green at the bottom, we have our standard form. Sometimes it's going to be easier to go slope-intercept form first, then standard form, but in reality, it really doesn't matter. Each has their functions and each has their special methods to work through it. Let's look at the second part of our example. As we look at our second part of our example, we have the slope being 2/3 and the point being negative 4, 6. Let's start once again with point slope form. So y minus 6 equals 2/3 times x plus 4. It's a plus 4 because our x1 value is a negative. There's our point slope form. Very quick, very easy. On this problem, I have a fraction, so I'm going to distribute my fraction to my right-hand parentheses on my next step. And we're going to switch to purple here. So y minus 6 equals 2/3 x plus 8/3. If I want to go to slope-intercept form, I'm going to need to add 6 to both sides. Now as I add 6 to this side, I'm going to change it to 18/3 because that's going to be in terms of thirds, giving me y equals 2/3 x plus 26 thirds. So that's going to be slope-intercept form. Moving from slope-intercept form to standard form is going to be very simple. We're going to multiply everything by 3, giving us 3y equals 2x plus 26. Then we're going to subtract 2x from both sides, giving us an answer of negative 2x plus 3y equals 26. And that's going to be our final standard form. So the manipulation back and forth is just good practice of manipulating fractions and manipulating equations. Each of these forms is useful. The most graphical form is the slope-intercept form in purple. Standard form is used for solving systems of equations, and point-slope form is just the most basic form to start with which we can go in any direction that we want. Let's move on now and talk about finding slope and finding the equations when we're just given 2 points. Reviewing from yesterday, we're going to need to use the major equation for slope of y2 minus y1 over x2 minus x1. Let's take a look then and see where we're going from. Our point-slope form, I'm going to choose to start here and first find my slope of negative 1 minus 2 over 5 minus 0. That gives me a slope of negative 3 over 5. This is going to be key as we kind of look at how we're going to work through this problem with a negative 3/5 slope. The first thing we're asked to do is find all 3 forms. Let's find the easiest one first, which is point-slope form. Point-slope form, really, we're just going to plug in our values. We have 2 options for an answer. The first option will be y minus 2 equals negative 3/5 times x minus 0. Or a second point-slope form could be written with the other point as y plus 1 equals negative 3/5 times x minus 5. Either of these forms is a correct form for point-slope form, depending on which method we're going to go next. I'm going to go with the x minus 0 because obviously it seems to me like that's the easiest one, and we're going to kind of take that to another level as we kind of work this out. That gives me y minus 2 equals negative 3/5 x. If I add 2 to both sides, I very quickly arrive at my slope-intercept form, the slope being negative 3/5 and the y-intercept being 0, 2. So just as a little note there, slope is negative 3/5 once again, and the y-intercept, the b value, is a value of 2. That makes it very quick for sketching. If I want to take this and take it to standard form, I can multiply through by 5, and that'll get me to standard form. So I'm going to multiply everything by 5. 5y, negative 3x, and 10. I add 3x to both sides, giving me a final answer of 3x plus 5y equals 10. So there's my standard form. Let's look at our other one. First step, once again, finding our slope. M equals 0 minus negative 3 over 1 minus negative 2. That's positive 3 over positive 3. So my slope is 1. It's not always going to happen that way, but sometimes it might. For point-slope form, going from there, I'm going to choose the point 1, 0, because that seems to be the easier point to work with. What will that give me? Y minus 0 equals 1 times x minus 1. Or in simple form, y equals x minus 1. Very straightforward. All right, moving down. To go from here, forgot also to intercept, this is slope-intercept form over here on the left. If we want to go to slope-intercept form, I'm going to just we simply write it as x minus 1 and distribute that 1 to the positive. So slope-intercept form. All right. How do we move from that to standard form? I think it's really straightforward. We're going to subtract x from both sides, giving me negative x plus y equals negative 1. Maybe I'll multiply everything by negative 1. X minus y equals positive 1. And so there in green is our standard form in both parts at the bottom. Okay, so as we've looked at this, we've talked about finding slope, finding point slope form, finding the slope intercept form, finding standard form when we're just given 2 points. Let's move on and look at some different scenarios. Here we're given some equations and we're asked to write the slope intercept form from them. So just a very simple practice. Given standard form, we want to get the slope intercept form. In basic summary, that means we're going to need to solve for the variable y. To do that, we need to isolate that negative 5y first by subtracting 2x from both sides. Remember that 15 and negative 2x are not like terms, and I'm going to write it down just like so. Some of you may be asking me, why did I put the 2x first? I'm anticipating slope-intercept form, remembering that mx comes first and then the b. My second step will be simply to divide everything by negative 5. Remembering to divide all 3 by negative 5, giving me a final answer of y equals positive 2/5 x minus 3. Need to correct a small error that I just saw. That x there is actually supposed to be a y. So there's our equation. Y equals 2/5 x minus 3. Let's look over here at number b. We're going to subtract 4x from both sides like we did before, giving me 3y equals negative 4x plus 11. We're going to divide everything by 3. This gives me an equation of y equals negative 4/3 x plus 11/3. So, as we summarize and kind of look back at these, on this one, the slope is 2/5. The value of b is negative 3. Over here, the slope is negative 4/3, and the b value is positive 11/3. If you were graphing that, that would be somewhere between 3 and 4, closer to 4. Our next example, we're asked to find the slope of the line given, and then we're going to write the equation in its point slope form, and then either standard form or slope intercept form. Maybe we'll do both of them. As we look at this line, we have to identify some points first that we can clearly see are at intersections. I see this one here, and we can continue to look for points. I see that one there. That's a key one. That's the y-intercept. I'm going to put that one in red. 0, 2. 0, negative 2, excuse me. So it looks like my points are very simply, consistently going down to the right, and they have a pattern of going down 1 and over 2 for each of these small triangles. So down 1, over 2. Now if we remember about slope, slope is rise or fall over run. So I feel like my slope on this one is down 1 over 2 as a consistent situation. So that's a great way to start with our slope. Now, I'm just going to pick this point here. I'm going to call it point A, and that's 1, 2, 3, 4, 5, negative 6, comma 1. And I'm going to use that as my point. So here we go. Y minus 1 equals negative 1/2 times x plus 6. There we go. That quickly we have point slope form. Could you have used a different point? You bet. We could have used just as easily this point over here. 1, 2, 3, 4. 1, 2, 3, 4. And we could have used that point as 4, comma 4. 4 comma negative 4 just as easily for point-slope form. Now we're going to write slope-intercept form. Remember, that's y equals mx plus b. I already know the slope is negative 1/2 x, and if you remember, the b value is right here at 0 comma 2. So the b value is 2, or is it negative 2? I think I correct myself and say it would be 0, negative 2. So 1/2 x negative minus 2, and there is slope-intercept form. We might as well do standard form as well. We're going to multiply everything through by 2, giving us 2y equals negative 1x minus 4, and then add the 1x to both sides, giving us x plus 2y equals negative 4 for our standard form. And so there very quickly we have 3 different types of forms when we're given the points on a line. Our last example page involves finding the slope and then quickly sketching. Well, slope and y-intercept are going to be our key ideas, but we're going to have some other things that might pop up on this page. On A, my slope is 2. My y-intercept is negative 3. Realize that's 2 over 1, so I'm going to quickly go to negative 3 and go down 2 over 1 and follow that pattern as far as I can. When I run out of space going down and to the right, I'm going to go up and to the left the same way. Remember from yesterday, we have the ability to draw a line using the line function. So we're going to draw that line through our points as best we can. I'm going to select flatten, and that's going to take my line as best as possible and put it there on the graph. On part B, we're given the form in standard form. When we're given this form, we could solve it and put it into y equals mx plus b form. But I want to show you an alternate method, which would be to find the x and the y-intercepts on this in order to very simply find those and graph using those 2 points. To find the x-intercept, you're going to say that's going to happen along this line, horizontal line here, when y equals 0. So if y equals 0, that's going to drop out the y's completely. So in your mind's eye, the y's become 0, which gives you an equation of negative 3x equals 24. That means x equals negative 8. So there very quickly we have the point negative 8 comma 0. So 1, 2, 3, 4, 5, 6, 7, 8. There's my point in red. The y-intercept is where x equals 0. And if x equals 0, we're left with the equation 4y equals 24, which gives me y equals 6. That's the point 0, comma 6. 1, 2, 3, 4, 5, 6. And just that quick, we've got our line. So, as we're looking at these points, we've got some x and y-intercepts. We did it that way with part B. We did the slope and the y-intercept with part A. Could you have solved part B by adding 3x and dividing everything by 4 and getting a slope of positive 4/3? You bet. We still would have gotten the 6 there, but just to show you that that is a positive 4/3, I'd like you to count with me. A positive 3/4. We're going to go up 3, 1, 2, 3, and over 4. And that gets us to this point, and then up 3 more and over 4 to our second point. So it does have a slope of 3/4 going to the right. Let's look at point C. This is set up in point slope form. It has a point, negative 2, comma 2, and a slope of negative 4/5. Graphing from this information is very quick. We go to negative 2, 2, right there. From that point, we're going to go down 4 and over 5 to another point, and then down 4 and over 5 to another point. Going backwards, we can go up 4 and over 5. That gives us 4 points on our graph with which we can draw our line. X equals 4 presents an interesting situation because we don't have a y value. When we think about the idea of x equals 4, I guess that means y could be anything. So we could have the point 4, comma 0. or 4 comma 1, or 4 comma negative 3, or 4 comma 5. If we were to graph all these points on our graph, we quickly see that all of these points are representative of all the red dots that would be up and down on this vertical line. And that vertical line, therefore, is the line x equals 4. So let's draw that line x equals 4. Over here on E, we have all the points where y equals 3. Once again, it has no matter what the values of x are. So let's say, hey, that could be 0, 3, or 2, 3, or negative 5, 3, or 6, 3. I'm sure you get the point. So if I were to graph those points, very quickly it would become apparent that you have all the points that are on the horizontal line, y equals 3. So let's draw that line. All the points where y equals 3. Part G, we're asked to find the slope there. To find this slope, we're going to have to solve for y. So we subtract dx from both sides. Excuse me, we need to get back to a pen and get rid of that. So we're going to subtract dx from both sides. That gives me negative ey equals negative dx plus f. Now we're going to divide both sides by negative e. That gives me y equals d over e x minus f over e. What is the slope? Hopefully you see it's d over e. Now, I think I was remiss in realizing that maybe we didn't find the slope of all of our problems. On part B, we didn't go back and actually find the slope of part B. So let's do that right here. Negative 3x plus 4y equals 24. We were to add 3x to both sides algebraically, so 4y equals 3x plus 24, and divide both sides by 4. That gives us a slope of positive 3/4. We did find the slope on C, but on D, we didn't reference what the slope was. A vertical line, if you remember, has the idea of no slope. Or it could be thought of as undefined. On part E, a horizontal line has a slope with a value of 0. So, just to make sure that we've got all of our ideas, there's our slopes for each of our parts. Let's go back and review before we conclude. We started off by talking about 3 forms of slope: point slope, standard, and slope intercept. We determined that we could find all of those different forms by manipulating the equations and solving for various forms. Then we found a reminder of how to find the slope using the equation y2 minus y1 over x2 minus x1, and we found our various forms of slope again, always starting with the point slope form in blue. We then realized that we could solve for y to find slope intercept form, which gives us the slope and the y-intercept, which are often easy to graph with. Then we used a graph to find points, from which we found the point slope form. And then finally we took a variety of different types of equations and we drew them on their graphs with a quick sketch. We found the slopes of each of those as well. All right, so our homework tonight is in section 2.2 on page 68, numbers 20 through 37 and 43 through 46. I've given you some graph paper on the below page because I believe you have a couple graphs that you're going to be needing to do. I hope you'll find you're successful as we continue our adventure through equations of lines.